What's up, operators? This is Reps4Thor Weekly, week 2. Today we're talking about Cloudflare, and I'm going to do 3 things with it. If you've ever bought a domain, pointed it at name servers, and suddenly your site got faster, gained a padlock, and started blocking weird traffic, there's a decent chance you've met Cloudflare already. At its core, Cloudflare is an internet infrastructure company that sits between your users and your servers. Think of it like a very large, very distributed layer in front of millions of websites and apps. It can speed things up, filter and block malicious traffic, handle denial of service attacks, and generally act like a bouncer and a delivery driver at the same time. Cloudflare has a global network with data centers spread across hundreds of cities and more than 100 countries. The idea is that when a user in, say, Atlanta tries to load a site, Cloudflare can serve the content from a location close to them instead of making the request travel across the planet to a single origin server. Less distance, less latency, faster pages, happier humans. Now, Cloudflare is not just one thing. People think it's a CDN, but it's really a stack. And that leads us to the second part. Why Cloudflare affects the global internet. In late 2024, Cloudflare itself said that about 20% of the web runs through its network. Let that sink in. But the trade-off is centralization. Now, here's where I want to slow down and be fair. It also has bot management, rate limiting, and challenge systems like Turnstile that decide, are you a human, a good bot, or a gremlin in a hoodie? Let's start with what happened on November 18th, 2025. Cloudflare later published a post-mortem saying it was not caused by an attack. The trigger was an internal change. A permissions change in one of their database systems caused the database to output multiple entries into a feature file used by their bot management system. That feature file grew larger than expected and got distributed across their network. That outage was measured in hours, not seconds, and it affected core traffic delivery, challenges like Turnstile, and other dependent systems. The important point for us isn't the brand name of the internal database or the exact file format. Now, a few weeks later, on December 5th, 2025, we got another significant incident. Cloudflare reported that the outage started around 8:47 UTC and was resolved around 9:12 UTC, so roughly 25 minutes of impact. The trigger this time was changes being made while trying to detect and mitigate an industry-wide vulnerability related to React server components. Cloudflare addressed this directly a couple weeks after those incidents. They announced a resilience plan they called Code Orange Fail Small. So their plan focuses on requiring controlled rollouts for configuration changes that affect traffic, improving and testing failure modes, so systems behave predictably under unexpected states, and tightening their internal break glass procedures so they can respond during incidents without getting trapped by circular dependencies. And the question is, how do we build systems that fail small, recover fast, and don't take the neighborhood down with them? First, what Cloudflare actually is in plain English without the marketing fog machine. Second, why Cloudflare has such a massive effect on the global internet, and why you sometimes feel like half the web is down when Cloudflare sneezes. Third, what's been going on with some recent Cloudflare outages, why they happened, and what those incidents teach us about modern internet infrastructure. All right, Cloudflare. The simplest mental model is this. Instead of every visitor talking directly to your web server, a lot of them talk to Cloudflare first. Cloudflare receives the request, checks it, maybe caches it, maybe blocks it, maybe challenges it, and then forwards the good stuff to your origin server. That sits in front. Positioning matters because it's not just a product feature, it's a physics feature. It's a CDN, meaning it caches content and serves it from the edge. You know, it's a reverse proxy meaning it can terminate TLEs, inspect requests, and then pass them along to the origin. It offers DNS, meaning for a lot of domains, Cloudflare is the place your computer goes first to find the IP address of the website. It provides DDoS protection and web application firewall rules, so if somebody tries to flood your site or hit it with malicious payloads, Cloudflare can filter that traffic before it ever reaches your server. And then there's the developer side. Edge compute, serverless stuff, workers, and all the modern run code close to the user magic. So when someone says Cloudflare, they might mean my DNS or my CDN or my security edge or my zero trust access or all of the above. About 1 out of every 5 websites you visit and a huge amount of traffic from apps and APIs is passing through one company's edge network. That doesn't mean Cloudflare owns the internet. It means Cloudflare is one of the big choke points where the modern internet's performance and security are concentrated. And there are upsides to that. The upside is speed. Caching and routing at the edge makes the web feel instant. The upside is security. A lot of the nastiest traffic gets handled before it hits your servers. The upside is reliability for many customers. Distributed networks can absorb attacks and route around trouble. When you build the internet like a city, Cloudflare is one of the major interstates. If there's a wreck, you don't just lose one neighborhood, traffic backs up everywhere. That's why outages at infrastructure providers feel surreal. You refresh, your favorite site is down, your work dashboard is down, your status page for checking what's down is also down, and suddenly you're staring at a browser like it owes you money. Cloudflare has an insanely hard job. They are handling enormous amounts of traffic. Malicious traffic is constant, and the internet doesn't give you a polite maintenance window. There's always an attacker somewhere doing something dumb, and sometimes doing something smart. But when you have that much of the web passing through your systems, tiny mistakes can have big blast radiuses. And that takes us to the recent outages. A lot of people woke up, tried to load sites, and got errors. Major platforms and services saw issues, and the vibe across the internet was basically, did we just lose the web? Now think about what that means in plain human language. A system that helps classify bots uses a configuration-like file, and that file ballooned. The bigger file got propagated very quickly across a huge fleet of servers. Yeah, and then things started falling over. Cloudflare described a pattern where the system would recover and then fail again as good and bad versions of that configuration were distributed, which also made the situation confusing at first. They initially suspected they might be dealing with a giant denial of service attack because the symptoms looked similar from the outside, but eventually they identified the core issue, stopped propagation, replaced the problematic file with an earlier version, and traffic largely started flowing again. The point is the pattern. A change happened. The change produced a bad artifact. That artifact got pushed broadly. And because the system is global and fast, the failure was global and fast. This one was shorter, but it still hit hard. Cloudflare said a subset of customers were impacted, accounting for about 28% of all HTTP traffic served by Cloudflare, and that several conditions needed to line up for a customer to be affected. Again, they said it was not a cyber attack. Here's the part that matters. When there's a new vulnerability in a popular framework, defenders are racing the attackers. You're trying to deploy protections before the bad guys start mass scanning and exploiting. Cloudflare was rolling out a change related to their web application firewall's request body parsing. They increased a buffer size as part of protecting customers. During rollout, they noticed an internal testing tool didn't support the new buffer size, so they made a second change to disable that tool. And the second change was applied through a global configuration system that propagates changes across their network in seconds, not gradually. Under certain conditions, That triggered an error state in their proxy that resulted in HTTP 500 errors until the change was reverted. In other words, a safety-motivated change made under time pressure, combined with how fast global configuration can spread, and a software bug that didn't show itself until it was in the wild. This is where people on the internet go, see, you can't trust anybody. And I get the frustration because when you're a customer, an outage feels personal. Your site is down, your business is down, your users are yelling, your coffee turns into despair. But I want you to take a different lesson. The lesson is that the internet is now built on extremely powerful, extremely centralized platforms. And the hardest part isn't building the platform. The hardest part is changing it safely. This is why change management is a security topic, because the same mechanisms that make Cloudflare powerful, like pushing configuration fast globally, also create the risk of pushing the wrong thing fast globally. And the basic idea is stop failing big. They described how both outages followed a similar pattern where a configuration change was deployed essentially instantaneously across data centers in hundreds of cities around the world. They said they already do controlled rollouts for software releases with gates and monitoring, but they hadn't applied the same methodology to configuration changes in the same way. That last part matters more than most people realize. During a major incident, you need to be able to access your dashboards, your controls, your authentication systems, your internal tools. If your own products depend on your own products and one domino falls, suddenly the people who can fix the problem are fighting through the same flames as everyone else. So when I look at these outages, I don't see Cloudflare bad or Cloudflare good. I see a case study in what happens when the internet runs through a handful of mega providers, because Cloudflare is not the only one. We've seen similar ripple effects with other big cloud platforms, DNS providers, and identity providers. The modern internet is fast, but it's also tightly coupled. You know, when you couple systems tightly, the best days are amazing. Everything is instant and scalable. You know, but the worst days are dramatic because failures propagate. So what do we do with that? As normal humans and as builders, if you're just a person using the internet, the main takeaway is to understand why outages cluster. It's not that every site suddenly broke at the same time. It's that many sites share the same infrastructure. If you run a site, an app, or a service, here are a few practical mindset shifts. Know whether Cloudflare is in your critical path as DNS, as proxy, or both. Those are different failure modes. Have an incident plan that includes the possibility that your edge provider is impaired. That doesn't mean you can instantly switch the internet like a light switch, but you can plan what you communicate, what you monitor, and what you can bypass. Avoid assuming that multi-region or multi-cloud automatically saves you. If your DNS, WAF, and delivery are still centralized in one place, you can still get taken down by a single systemic issue. And on the flip side, don't overcorrect into chaos. Most people don't need to run 3 CDNs in a home-built BGP mesh just to post photos of their dog. Please don't become that guy. Your dog deserves peace. Instead, be intentional. Understand dependencies. Reduce single points of failure where it makes business sense. And test what you can. Also, if you're a creator, a builder, or a small business, remember this. Cloudflare is popular for a reason. It's usually an upgrade. It usually makes you safer. It usually makes you faster. The existence of outages doesn't cancel the value. It just reminds you that even the best infrastructure can stumble, and when it does, the impact is global. And that leads me to the closing thought I want you to keep. We talk a lot about attackers, but defenders have a different enemy too: complexity. Every layer of modern infrastructure adds power, but also adds complexity. And complexity is where weird failures live. So the question isn't, how do we build systems that never fail? That's the real game. All right, operators, that's week 2. Yeah, if you want a simple challenge for this week, here it is. Pick one website or app you rely on, go look up what services it's using at the edge, and map the dependency chain in your head. CDN, DNS, security, identity, analytics. Just identify the major dependencies and think about which ones would take it down if they went sideways. You don't have to change anything. Just build the mental model, because once you can see the dependency graph, you start seeing the internet differently. You stop thinking in brands and start thinking in systems. This is Reps for Thor in transmission.